Your zero point 0.1 micron filter stops Giardia, but it is physically incapable of stopping hepatitis A, and one night below freezing turns that filter into a useless, invisible straw. You trust hollow fiber filters like the Sawyer or Be-Free because the flow rate is seductive. But in high-risk viral environments or freezing temperatures, that mechanical barrier becomes nothing more than a placebo. We engineer systems to manage 3 biological threat tiers: protozoa like Giardia, bacteria like E. coli, and viruses like norovirus. Standard hollow fibers filter down to 0.1 microns, effectively blocking the first two based purely on physical size exclusion. The physics of exclusion is absolute. A 0.02 micron virus passes through a standard 0.1 micron pore with zero resistance, like sand thrown through a chain-link fence. This is why filters differ from purifiers. Purifiers must hit the 0.02 threshold. Inside the casing, thousands of U-shaped microtubes operate via hydrostatic pressure. This design maximizes surface area for flow, but creates a catastrophic structural vulnerability when thermodynamics comes into play. Water expands by approximately 9% during the phase transition to ice. If moisture remains trapped in the fibers, this volumetric expansion generates pressure, P ice, that exceeds the tensile strength, sigma, of the polymer walls, causing microfractures. The danger is the invisibility of the failure mode. A compromised filter flows faster and looks identical to a functional one. You won't realize the breach occurred until the incubation period of the pathogen ends days later. To neutralize viruses or manage freeze risk, we switch from mechanical separation to sterilization. Chemical oxidizers like chlorine dioxide or UV radiation target the DNA or RNA directly, disrupting replication regardless of particle size. However, chemical kinetics are strictly governed by temperature. Chlorine dioxide requires significantly longer contact time in near-freezing water to achieve the same log reduction in viral load. Read the datasheet, not just the marketing label. Assess your risk profile systematically. If you are near human impact, sewage infrastructure, or grazing livestock, the viral probability spikes. If temperatures drop below freezing, mechanical filtration integrity is compromised. Treat hydration as a sterile systems problem. Carry a mechanical filter for turbidity and speed, but maintain a chemical backup for viral defense and redundancy against the physics of freezing. Understand the microscopic threat landscape. Gear failure is usually user error.